Okay, we have our table of values here. Then we have addition plane here. But since for now, I'm not drawing it, I'm using freehand here, I'm not drawing it to scale, so you will manage my graph. But it should give us exactly what we are looking at by the time we create this. So let's graph our quadratic function firstly. So when x is negative 2.5, y is what? 2.87. So when x is negative 2, this is negative 2.25. We have what? 2.8. Negative 2, somewhere here, go up 2.8 close to 3. So we have something about this place. Yes, the next one is negative 1.25, close to 1. Then we have the corresponding negative 3.1. Oh, we're going down. Negative 3, negative 3.1. Immediately after 3, just under 3. And that's here. Then we have negative 0.25, close to 0. Then we go down to what? Negative 5. Negative 5.12. We go down just a bit after 5, close to 1, a bit after 5. So this is it. We have this here, this, and this. Then we go to the next one. 0.75, close to 1. It's corresponding with what? Negative 3.1. So it's corresponding with this. Close to 1. It's corresponding with this. Then what do we have next? 1.75, close to 2. Is what? 2.87. This is 2.8, close to 3. And we have this here. So if we connect our dots, we should be looking at something like something about this. Yeah, it's not perfect, but I mean, you can manage. Alright, so we have this now. So the next step, okay, the next step now, we have our quadratic graph. The next step now, we want to look for the point of intersection. We've only done for this quadratic. We have not attended to this one. Now, what they want us to look for a point of intersection is where these two lines meet. And where they meet, if you want to illustrate that with your mathematics, it's going to be if y equals y. Therefore, 2x squared plus x minus 5 equals what? 3 negative x. Have you seen it? So if we bring everything this way, we're going to have what? 2x squared. Negative x becomes what? Positive x. Plus this we have what? 2x. Positive 5 comes in becomes what? Negative 5, right? We have what? Negative 8 equals what? 0. That's what we have now. Negative 8 equals 0. We are now going to solve for x. Are you with me? Alright. We equated y, if y equals y, therefore 2x squared plus x negative 5 equals 3 minus x. So we did that equation. The essence of this equation is to get the values for x. And if we solve this quadratic equation, we're going to get x equals negative 2.6 and x equals what? 1.6. But I didn't know that this is a quadratic expression. I should be able to solve that. Now, we remember we equated this. That means this equaling this means where the equation bisects these 2 points. That is what it means. So equate one equation with the other, it tells you the point of intersection. The point of intersection is being equating this. So at the point of intersection, x was negative 2.6 and x also was 1.6. We are going to tell that with our graph. We have the second expression. Remember, we have a linear function here. Y equals 3 negative x. Now, if we're going to express that as y equals 3 negative x. Now, if I want to rewrite it, say y equals what? Negative x plus 3. Now, what does this mean? This means that our slope is what? Negative 1. Remember, a negative slope means that we are going to have what? Fall 1 and run 1. Fall 1 and run 1. Our slope is what? Negative 1 over 1. So because it's negative, we fall and we do what? We run. We fall 1 and we do what? We run 1. But our graph is going to start from where? From 3. From 3. So from at this point 3, we fall 1 and we run 1. So we start from here. and 3. We fold 1. From here, we come down to 2. That is folding of 1. Then we run. From here, we run 1 with respect to our x axis. It's going to be what? We run 1 from here. 1. These are points. If we fold 1 again, from 2 we fold to what? 1 on the y-axis. Then we run 1 from 1, we run towards 2 on the x-axis. So that's our second point. We could still go on and on and on. So if we fold 1 on the y-axis, from 1 we fold out to what? 0. Then on the x-axis we move 1 again, from 2 we to what? 3. So we could do this all day. So this is the line we are concerned with. This is our what? Now we need to go back. We need to go back. If we go back this line, remember we're coming like this. In order to go back like this, we need to do what? Rise over run. So if we rise 1 and we run 1, we are going to be at. If we rise 1 to 4, run 1 to negative 1. We have it somewhere about this place. If we rise 1 again to 5 and run 1 to what?
Negative 2.
Negative 2. We should be having somewhere around here. Then if we rise 1
6.
and run 1 to what? Negative 3. We should be here. So my line will not be too perfect, but at least to manage. Now, that is our linear graph. That's our linear graph. Now the question is, where is our point? Alright, so this is our linear graph. You see, yeah, I used freehand here, so it's not as perfect as to be a graph. But this is our linear graph, and here's our quadratic graph. Now we need to find the solution. But we already know when x is negative 2.5, we don't got our y. So the first thing you want to do is to take the linear equation. It's easier to get your y here than putting it here. Because to be more effective. Now let's do y equals to 3 negative. When x is negative 2.6, what do we have? Y equals to what? Positive 3 plus 2.6. That was 5.6. That's what we got here. When y is 5.6. So when y equals negative 2.6, we got when x equals negative 2.6, we got our y at 5.6. We can create that point. You could say we create the coordinates by writing negative 2.6 comma what? 5.6. This is the coordinate of the first one. Then for the second case, we could just solve x when x is what? 1.6. Let's have it. When x is what? 1.6. So we're going to have y equals to 3 minus 1.6. 3 minus 1.6 is what?
1.4.
So we have it what? 1.4. So we can write it here. When x is 1.6, y is what? 1.4. Now, these two values we have here, they are our solution. They are the solution to the question that we given. These two. But we need to check for the corresponding value of y. When x is negative 2.6, y is what? 5.6. When x is 1.6, y is what? 1.4. Let's check. Let's check. This we have this here. Like I said, it's not drawn to scale, but we can manage. When x is 1.6, y is what?
1.4.
You could see this is our graph. It tells us that at this point this is closer to 2. That we can assume that to be 1.6 because we're not drawing to scale. And you can see this is about half. That is 1.4. So when x is 1.6, y is what? 1.4. So we can track the second one. Negative 2.6 and what? 5.6. So 5.6 should be close to 6 rather than 5. So let's take it to where they meet. This is where they meet. Now trace it down.
Negative 2.6.
Let's go down. See, if we trace it down, we are close to almost half of this. So when x is negative 2.6, y is what? 5.6. So this becomes our solution. This becomes our solution. This and this place. So if for using the graphical illustration, we just cancel this place and this place. So this is the solution of the equation that we're given. This when x equals 2.6 negative 2.6 y is what 5.6. When x is 1.6 y is what 1.4. And so this is the graphical illustration for that expression. So for one linear word quadratic, in most cases you want to do it like this. It is easier when you are giving values for x, but in this case we are not giving values for x, so we use the vertex method to solving our getting our points, then we generated other points from there. We got our quadratic equation. Then this linear equation we equated it to the quadratic equation, so I can get our point of intersection. Then we solve for x. Solving for x, we use our value for x to find y, then we got our solution. It is very good. This graphical illustration just explains everything here. So this expression is this place here, but in terms of graph. So please take your time, go through it in case you do get it, you mind and get the whole information of anything. Then you drop a comment if there is any need for you to. If there's any place you need more question and more explanation, do that. Thank you.
Thank you.